The SATFIRE project, or Satellite Data Fusion and Imaging Resolution Enhancement for Coastal Areas, is a project which seeks to address an issue with thermal satellite imagery. The issue is that these type of data tend to be provided at low spatial resolution, however benefiting from high revisit times, so we would have data for the same location every 1 to 2 days. Now, sea surface temperature data is an important input into certain hydrodynamical models which are used for the forecasting of marine currents. So by improving the spatial resolution of the satellite imagery, we would be able to provide more accurate forecasts which would benefit users such as divers, fishermen, swimmers, and also for applications like the tracking of marine pollution and debris.
There are 2 departments working on the project, the Department of Communications and Computer Engineering and the Department of Geosciences. During this project we had recruited 3 researchers, 2 master students, 1 in each department, and we had also a postdoc working in the Department of Communications and Computer Engineering for 18 months.
This project saw the collaboration between not just 2 departments, but 2 faculties. The Faculty of Science also involves the Department of Geosciences. Now, as part of the Physical Oceanography Research Group, we study the sea. So just to give an example, if I drop this rock on the ground, there is an equation that explains where and when it will hit the ground. The same thing we do with the sea. There is a set of equations that explain how the sea is going to move in the next couple of hours. And we do so not by a calculator and a piece of paper, of course, but by giving the computer a set of instructions, a set of codes, to solve these equations, telling us where the sea is going in the next few hours. Now, how is this project helping us with this model? This model is a forecast, very much like the forecast for the air, to check if it is going to rain tomorrow or if it's going to be sunny. We do the same thing for the sea. This project is helping us because every now and then, daily, we need to check if the model is going in the right direction, if the model is giving us realistic forecast. And so a higher resolution of sea surface temperature as observed from the satellite would enable us to compare this model to check if it is good, if it is a valid result. A more accurate result would help us because those who use the models, particularly fishermen, sailors, and anyone who goes out at sea and needs to know these currents, would be able to use this model, a more accurate model, thanks to a higher resolution from satellite images.
The Sentinel-3 satellite provides sea surface temperature data at a resolution of 1 kilometer per pixel, and we used this as an input into the neural network, and the output that we used to train the neural network was Landsat 8 data, which has a resolution of 100 meters per pixel. The difference is that the Landsat 8 satellite passes over the same location every 16 days, so it cannot be used for applications such as current forecast monitoring. However, we could use this data in order to train our neural network, and we were able to obtain a performance which exceeds that of standard interpolation techniques by training this artificial neural network.
The major challenges were basically 2. The first one was because the high-resolution thermal images had striping artifacts caused by miscalibration in the satellite. And the second one was the resolution of the Sentinel-3 camera, which has a resolution of 1 kilometer per pixel. And our target of the project was to achieve a 200-meter resolution. The method was already implemented and tested in a real-world environment, although we can try to improve the algorithms using more advanced deep learning architectures. Another thing that we can do is to make the code available to the public so that other research institutes can use it in their domain.
The project received 150,000 euros in funding from the Malta Council for Science and Technology and was financed for and on behalf of the Foundation for Science and Technology through the Space Research Fund.